everybody. My name is Kam Hong, and I'm the Director of Business Development from Oracle's Hybrid Cloud Systems Group. So today I'm going to talk about data resiliency and protection and its importance to success and resiliency. Let's get started. Data, as we know, is growing exponentially and is without a doubt that data is a new oil in the digital economy and have also become an organization's most valuable asset. Ironically, most businesses are struggling to manage and protect these valuable assets because of legacy approaches to the problem. With the rapid changes to the technology and threat landscape, data protection must take a revolutionary step. Data protection is all about the ability to recover from failures, resiliency, and data agility. As a result of typical industry norms, database backup and recovery is still a top IT challenge and an expensive proposition to customers. Here's a case study of a leading global financial firm that have shared with Oracle the experience that they have encountered in their environment. They encountered 4,000 failed database backups per month. 60% of all of their restores were failing, and it cost an outrageous $2.5 million each year to correct these backup and recovery shortcomings. On top of that, there are regulatory compliance issues that need to be dealt with, such as non-compliance penalties for not achieving the stated RPO and RTO set by the regulatory authorities. Traditional data protection, as we know it, is failing organizations. Ransomware. Ransomware is really a modern-day version of a bank robber in the Wild West. Resilient recovery with no data loss is a foundational requirement for data-driven businesses. Therefore, ransomware is an extremely important, if not the most important, data protection topic on our customers' minds. It has become the greatest threat to business survival in modern times. Even more concerning is the news that ransoms are actually paid on a regular basis in the hope of regaining access to data. We are talking about multi-millions of dollars. So it's clear that today's recovery solutions and processes are not sufficient to get these systems back in a reliable and timely manner. And customers have no other option than paying the ransom in many situations. For databases, this can have a huge impact since we are talking about transactional workloads, and a compromise can affect, even if not caught for a few minutes, hundreds or even thousands of transactions that can literally represent hundreds of lost orders for a manufacturing company or millions of dollars worth of financial transactions in the bank and so forth. This is why protecting databases at the transaction level is especially critical versus traditional backup approaches. So what is your confidence level in the ability of your organization in recovering business critical data? Data recovery depends on valid backups, and as can be seen in the earlier example, backup and restore failure is unfortunately very, very common. Restore is typically much lower than backups, and the reality is very few organizations test their restore capability. On top of that, traditional backup processes also impacts production efficiency as backups consume computing resources and thus degrading performance. Business-critical relational data resides in Oracle databases. With 24/7 availability requirements, there's no way the database gets shut down to perform backups, which means backups are taken when the database is live processing transactions. Backups will need to be restored, then recovered to return the database to a consistent state. If one backup file is missing or corrupted, the databases can't be recovered, rendering the restored files useless. Confidence that backups are indeed recoverable requires database-aware backup validation at the transaction level. The recovery appliance is an Oracle engineered system delivering unique database-aware capabilities, which provides recovery assurance, predictable backup, and restore performance, as well as offloading workload from database servers and network. In a nutshell, the recovery appliance reduces complexity and risk How can I say that with such confidence? When it's time to recover, you want to recover simply and quickly, with no mistakes. And that's where automation comes in. Automated database recovery is a good thing, especially when the pressure is on. It starts with our incremental forever approach, which uses less server, storage, and network resources, as it sends only the changes across the wire. With this incremental forever approach and constant real-time transaction protection, it enables us to easily recover to any point in time. When it's time to recover, there are 75% fewer steps to validate the recovery, incrementally restore and apply. Fewer steps means fewer chances for mistakes to happen. It's easy to set up data protection as a service for all your databases and all your database administrators. And because it's simple and automated, human error is kept to an absolute minimum. There is also flexibility in the solution to replicate the data to a remote appliance for disaster recovery purposes, or replicate to an air-gapped cyber-vaulted appliance to isolate threats and risks from a cyber attack. For long-term storage, backup copies can be sent to object storage in Oracle Cloud Infrastructure, Oracle's ZFS disk storage solution, and of course, also to Oracle's enterprise tape solutions. Let's see how does an incremental forever backup work under the covers. Firstly, the recovery appliance works like a time machine for databases. In traditional database backup techniques, the Oracle database host performs the brunt of the processing. Agents for this backup, tape backup, and duplication may all be running on the host. Furthermore, all backup operations, compression, validation, deletion, merging, and so on, occur on the database host. This overhead can greatly degrade database performance. Recovery appliance removes almost the entire load from the protected databases. The only backup operations required on the host, which could be primary database or standby database host, are sending incremental backups to the recovery appliance. The incremental forever strategy reduces the backup window on the database host significantly. Recovery appliance handles backup processing, tape operations, data integrity checks, and routine maintenance. Recovery appliance optimizes management of database changes using Delta Push and Delta Store, as shown in the figure. The net result of Delta Push and Delta Store is that the problem of lengthening backup windows is eliminated. The DBA performs only fast incremental backups and lets the recovery appliance manage the backup blocks. This solution consists of two operations that run on each protected database: the incremental forever backup strategy and real-time redo transport. Both operations involve protected databases pushing changes to the recovery appliance. In an incremental forever strategy, only one incremental level 0 backup, or what we call day 0 full backup, to the recovery appliance is required in the lifetime of each protected file. The initial level 0 backup does not contain committed undo blocks or currently unused blocks. In normal operation, the recovery appliance automatically performs the following steps for each incremental level 1 backup. Firstly, receives a scheduled incremental level 1 backup from each protected database. Validates the incoming backup to protect against physical block corruptions. Compresses the backup using specialized block level algorithms. Writes the backup to a Delta Store in a recovery appliance storage location. The incremental forever strategy greatly reduces the backup window and overhead because no full backups are ever required after the incremental level 0 backup. If the strategy includes real-time redo transport, then backup windows are further reduced because traditional archive block backups are not necessary. Also, recovery appliance takes on the burden of validation, deduplication, and compression. The Delta Store is a key processing engine for recovery appliance. A protected database sends only one incremental level 0 backup of each data file to the recovery appliance. Following the initial full backup, all backups are highly efficient cumulative incremental backups. As recovery appliance receives incremental backups, it indexes them and stores them in Delta pools. Each separate data file backed up to the recovery appliance has its own separate data pool. Recovery appliance automatically manages the data pools so that it can provide many virtual full backups. To create a virtual full backup, recovery appliance converts an incoming incremental level 1 backup into a virtual representation of an incremental level 0 backup. A virtual full backup appears as an incremental level 0 backup in the recovery catalog. From the user's perspective, a virtual full backup is indistinguishable from a non-virtual full backup. Using virtual backups, recovery appliance provides the protection of a frequent level 0 backups with only the cost of a frequent level 1 backups. Recovery appliance uses virtual full backups to provide rapid recovery to any point in time, regardless of the amount of data being recovered. The on-disk recovery strategy of recovery appliance has the advantage that RMN can recover virtual full backups to any point in time without applying incremental backups. When a database is protected by the recovery appliance, RMN must only restore a single level 0 backup for the day of the RPO and then recover up to the last second using redo log files sent using the real-time redo transport feature. So the value proposition of the recovery appliance is that it reduces overhead on database and backup infrastructure. Less overhead on database servers as a backup and recovery processes is offloaded from the database servers and thereby freeing up resources, allowing applications to run faster. Less LAN WAN traffic because of incremental forever backups approach. Less storage consumption because blocks are only stored once and backups are compressed on the recovery appliance. And finally, less personnel time needed because of simplified backup management by standardizing backup processes along with automated operations. Here is an example of a success story with Swisscom based in Switzerland. The customer was looking for a solution to reduce management complexity, increase reliability, and reduce the high integration cost of the legacy backup solution. By deploying the recovery appliance solution, this customer managed to reduce data loss exposure to sub-seconds with the real-time transaction protection approach. The backup storage consumption was reduced by 40%. On top of that, new backup configuration was reduced to 5 minutes versus weeks in their legacy backup solution. Protection policies. For complete protection policies can be created to define how backups are managed across the data lifecycle. Protection policies controls how long backups are stored by location, as well as automatic purging methodology. Protection policies control how backups are managed by first defining the recovery window goal. The recovery window goal controls how long backups are retained on the recovery appliance and automates the purging controls deletion of data based on available disk space. Next, we need to define recovery windows compliance. The recovery window compliance controls how long backups are retained on the recovery appliance and automates purging controls deletion of data based only on time. If there's insufficient space to meet the window, backups will be rejected. For archival storage stored on cloud, ZFS, or tape, a recovery window can be set up to control how long backups are retained on this external storage. Automated purging in this case is controlled by deletion of data based only on time. Here's another success story of energy transfer based in the US. This customer needed a solution to meet their SLA and increase the visibility of the backups across disk and tape. By deploying Oracle's recovery appliance solution, the customer managed to reduce their data loss exposure from up to 23 hours down to sub-seconds. They also improved the restore performance from 4 hours to 30 to 45 minutes. Backup window was shortened from 8 to 12 hours to 15 minutes. Storage consumption was reduced by 5 times. And finally, minimizing downtime during migration of 120 databases from 32 hours to 4 hours. Beyond the efficiencies of doing backups, it's important for a business to confirm and not just assume. For example, how many backups are validated? Are those validation done from a data-aware perspective, or just checksums? What is the current data loss exposure? Do you have the visibility? What is the point in time recovery capability? Again, do you have a visibility, and how do you know? How quickly data be restored? More importantly, has this been tested? Is critical data isolated from non-critical? In a nutshell, how confident are you your database backups can be successfully restored and recovered? Oracle's recovery appliance deploys end-to-end data-aware validation at the database level, and not just checksums like the rest of the traditional data protection solutions. Data is validated at every touch point. During backup ingest, the data is validated. When the data is stored in the appliance, periodically, the data is also validated. When the data is replicated to another appliance, upon ingestion of the data at the remote site, the data is again validated. At the remote site, the ingested data is again periodically validated. The self-healing architecture of the appliance also enables the corrupted data to be deleted and a good data copied when detected during validation. This ensures that you have 100% confidence that the data in the recovery appliance is not corrupted and can be recovered. Beyond the confidence of 100% recoverability, the recovery appliance also offers real-time database recoverability status. What does it really mean to have a real-time recovery status at your fingertips? This is a partial screenshot of recovery appliances database page showing 3 databases under management. You see the user-defined recovery window Go, what the current recovery window is by database, along with the current data loss exposure. For this example, we enabled ongoing transaction protection for only 2 databases, which, as expected, those have data loss exposure of less than a second, while the other database has 5.7 hours, which is the time since its last backup. Each database is assigned to a user-defined protection policy, which allows them to set a data loss exposure threshold. If any database exceeds that threshold, an alert is triggered. It completely eliminates the need for your team to babysit backups. Resiliency and recovery against cyber attacks. In recent years, cyber attacks have become a major concern for all customers due to the wide variety of approaches and subversive nature. Malware and ransomware attack cases are doubling year over year, according to a leading industry analyst, with millions of malware infections and thousands of ransomware attacks per day. For mission-critical databases, such attacks leading to lost data and system downtime can have far-ranging impacts throughout the business in terms of revenue, operations, reputation, and even penalties. The recovery appliance is designed to be fault isolated from the production database. So if a cyber attack hits the production database, the appliance is not compromised. This solution stems from the following key architectural features. End-to-end validation. While validation is a key to detecting corrupt backup data throughout the backup lifecycle, it is equally important for detecting cyber attack data. Since the appliance validates all incoming, on-disk, and replicated backups for Oracle block correctness and recoverability, any backup data maligned or by malware or ransomware attack will be detected, recorded, and alerted to the administrator. Action can then be taken in conjunction with the DBAs to disconnect the database from the network and investigate further. Furthermore, replicated backups cannot be deleted or modified by the primary appliance or its administrators. They are independently validated and managed by the recovery appliance, thus shielding from any effects of attacks done on the primary appliance. As an alternative or supplementary protection strategy, backups can be archived to Oracle Cloud Storage as a secure location for secondary backup copies. Using Oracle Key Vault as a key store for backup encryption keys, all backups remain encrypted in cloud storage, and users require access to the recovery appliance on an Oracle Key Vault to perform restore operations. Recovery appliance can also archive backups to fiber-attached tape libraries via Oracle Secure Backup. Tapes can be shipped to and stored in the network disconnected offsite location that is impervious to cyber attacks. With Recovery Appliance, DB, a database-aware incremental forever replication, the Vault appliance is configured behind a firewall, which is open only certain window of time during the day. Recovery appliance replication will proceed during those times to synchronize the Vault appliance. But when the firewall is closed, replication pauses. Upon the next open sync window, replication then resumes. With incremental firewall-based replication, only the minimum amount of data is required to maintain full recoverability from the Vault. No full backups as with general-purpose storage appliances, thus limiting the sync window and possibility of malicious access to the Vault. Separation of duty. Access to the system is controlled via strict separation of duty between DBA and appliance administrator roles. DBAs are only given virtual private catalog user roles to backup and recover their privileged databases. They cannot access, modify, or delete backups on appliance. Recovery appliance administrators only have access to manage and monitor the system, but cannot backup, recover, or modify protected databases. Furthermore, the appliance does not expose or allow creation of local users, databases, or other services. Limited network access. With regards to network protocols, VPC users can only connect to the appliance via SQLNet, while HTTPS is used for RMAN backup and restore traffic via the Recovery Appliance Backup module. No other protocols are employed. In addition, the appliance enforces network segregation with the support of VLAN tag networks, allowing backup and restore traffic to be fully isolated, non-routable between protected databases-specific network zones. In this way, any possibly affected backups would not be exposed to the rest of the enterprise. Superior resiliency. The appliance itself offers superior resiliency capabilities against cyber attacks when compared with traditional backup appliances. As an Oracle engineered system built on Exadata hardware and storage, the appliance inherits a resilient architecture for reducing surface of attack on compute and storage servers. This includes hardened password policies, OS and DB user auditing, firewall support, and Oracle integrated lights out management. Real-time monitoring and audit reporting. Enterprise Manager provides 360-degree view of database recoverability and system metrics. This includes audit report of all system access and activities, such as changing retention policies or deleting database backups, which could be evidence of malicious user. Finally, in the event that a database server is attacked and its backups must be recovered to a different server, Recovery Appliance real-time review transport allows recovery to the very last transaction prior to the attack occurrence. This is especially important for cyber attacks, such as ransomware, where the paying perpetrators does not always mean your data comes back in pristine condition. With Recovery Appliance, don't pay ransom. Just recover the database to a separate, safe location with no data loss. Here is another customer success story of a European global bank that was looking at a reliable recoverability and ransomware protection solution. By deploying Oracle's Recovery Appliance, the customer standardized 8,000 plus database protection on Recovery Appliance and managed to increase their backup and recovery operations by 4 times. Millions is projected to be saved by eliminating costly Tier 1 storage for backup staging in legacy environment. And as usual, the data loss exposure is reduced to sub-seconds. In essence, database recovery is all that matters. Unlike Recovery Appliance, most backup products focus is on backup and not recovery. Traditional backup products' weaknesses are the many backup silos that is needed with multiple diverse scripts and methodologies compared with one singular strategy in Recovery Appliance. Also, none of the traditional backup products is recovery aware and just make a big assumptions that the backup data can be recovered compounded with the fact that most companies only test 10% of their backups for validity. Recovery appliance, on the other hand, gives the customer real-time recovery status and the confidence that the data backed up can be recovered with its every touchpoint validation approach. Last but not least, traditional backup products only promote fast backup performance rates and not highlight slow and painful restore times. Recovery appliance offers same backup and restore rates, linear performance with scale out, and results published so that customers can plan accordingly. One last customer success story to be covered is this European large wholesale and retail food specialist who needs to replace their complex, expensive, and challenging long backup and recovery times solution. By deploying Oracle Recovery Appliance, the customer managed to improve their backups by 10 to 30 times. Enough said. Well, in summary, Oracle's Recovery Appliance solution helps organizations eliminate data loss through its real-time transaction protection, ensure database recoverability by doing a continuous backup validation, and database protection monitoring, reduces infrastructure utilization, and eliminate backup overhead through the incremental forever and compression approach. And finally, offers a resilient architecture through a database integrated hardware and software solution with cloud scale growth path. So in conclusion, what is your data protection strategy? Well, you can learn more about Recovery Appliance from oracle.com website or approach UST ECS to understand more about Oracle's Recovery Appliance. Thank you.